Hello everyone and welcome to today's session on Introduction to GD&T for Graduate Engineers. I am Gibson, Principal at the School of Postgraduate Studies at NTTF, Bangalore. I'd like to thank you for registering for this webinar and taking your time to be here with us today. Our next speaker, Mr. MS Muralidharamurthy. He has 37 years of profound knowledge and rich experiences in jigs and fixtures, cutting tools and gauges. A mechanical graduate from Germany and a senior faculty at the School of Postgraduate Studies. Over to you, sir.
Good morning to you all. Thank you, sir. Now, I will just give you a brief overview of GD&T. Introduction to GD&T. What is GD&T? It is geometrical dimensioning and tolerancing. So we are all engineers, we understand drawing. Drawing is a communicating language. So I'll take one example of a drawing and then I'll explain what it is. So there is a drawing here on the screen. So left side of the component drawing, one component drawing is dimensioned with coordinate dimensions. That is a dimension with plus minus tolerances are mentioned here. This is a coordinate, a simple drawing. And right side, if you see, it is the same component with geometrical tolerances, GD&T applied. See the difference here for communicating. So I'll just explain in the right side drawing GD&T. In this component, the requirement are clearly mentioned. It is a complete drawing. You can see this surface, flatness of this surface is mentioned here. How much it should be based on the function. And then datum system is defined. Datum A, datum B and datum C with reference to actual function of the part. And then you can see the perpendicularity orientation is a symbol which is used in GD&T. This surface should be perpendicular to two references, that is primary and secondary reference. Primary reference is datum A and datum B is secondary reference. With reference to these two, this should be perpendicular within 0.1. And then if you come to the profile, there is a profile tolerance, profile of a surface with reference to the datum and tolerance is mentioned here. And then the position of these three holes to be drilled for the function is given here with a position and tolerance. It is a GD&T symbol for position and tolerance is given with reference to datums. So in a datum system, there is a primary datum, secondary datum and tertiary datum with the tolerance and a modifier. It's given here. Okay, so this is a complete drawing which gives you all the requirements. In the same way, if you see left side, it is simple drawing and it doesn't communicate any requirements based on the function, whether how much it should be flat, how much it should be perpendicular and where should be the holes and what is the tolerance. Of course, it is given. How it is given? In a linear, it's a square tolerance zone. So 10 plus minus 0.25. Okay, and then 20 and 20 like that. So there is a tolerance accumulation after two holes, the third hole. Every hole after the first hole, the tolerance accumulation will be there. So it will affect the function. It may not get assembled. So it is not communicated clearly. The design intent, based on the assembly and the requirement is not communicated clearly in the left side drawing. This is coordinate dimensioning. So right side drawing, it is very clearly told here. So it is GD&T, if you use it, is a communicating tool and it is the complete drawing. Actually, it completes the requirements where we cannot in the case of coordinate dimensioning. Let us see some benefits. I mean, what do you call the points which we have to understand and the part, which when you give coordinate tolerancing, how it is unsafe. So in this actually undefined measurement setup, whether you measure from this side or this side, it is not mentioned. The 30 mm I can measure from this side also, or this depth I can measure from the surface, or from this top surface also. So there is no definite measurement setup explained in the drawing. Then no indication of measurement origin from where I have to measure. It is a square or rectangular tolerance zone. So from top x and y direction, it's a square tolerance. And from hole to hole, it accumulates. So which will have bad effect. It may not get assembled at the end. It will get rejected. It is a fixed tolerance zone. There is no flexibility for the enlargement of the hole within the tolerance for the position tolerance. Exact start point of dimension is undefined. Dimension, for example, if I take this 15 millimeters plus 0.5, is it from the top surface or is it from the bottom surface? It is not clearly shown. And the step here, is it from the bottom surface 6 millimeters or from this here? I can measure from anywhere. It is not exactly defined. So exact start point of dimension undefined. These are the actually drawbacks of the coordinate system. Measurement setup. Suppose if I want to measure on a surface plate, keep the component, and I want to check the height here. So if you take this reference and an angle plate, but the component here, and with after flushing this, and then I can measure the height. Okay, this is one method. So I am taking only this longer surface as the reference. It can be like this also. I can take the shorter length reference and measure the height. So whether this or this, which one? Which setup for measurement is intended? It is not mentioned clearly in the conventional drawing. So the functional dimensioning is very important. That is the philosophy of GD&T. So there are 6 major components of GD&T: fundamental skills, core skills, fundamental skills, vocabulary, definitions and rules. Core skills, concepts, understanding the concept, datum system and symbols used, and tolerance zones and its shape, location and orientation. And then application skills, linking to the function. So design philosophy is functional dimensioning. As you study the GD&T language, think of how each topic fits into this structure. Where GD&T should be used? To reduce manufacturing cost? Yes. To protect an important functional relationship on the part? To ensure that part can be assembled based on its function and reduce drawing revisions? There should not be any ambiguity in interpreting the drawing. And verifying, testing, verifying and inspection with the functional gauges. It is quick and then easy and improve measurement repeatability. Outsourcing is, with all this, outsourcing is possible. It is easy to outsource, and then finally you can analyze the design. With the tolerance stack-up analysis, you can analyze based on the function. Now there are 4 major benefits of GD&T. One is improves communication uniformly in the drawing specifications and interpretation. Wherever you are, whether you are a German or French or Italian, somewhere, some language, doesn't matter. This is throughout the world. This GD&T language is common. This is a symbolic language used in engineering drawings to convey design intent. So it improves communication. Outsourcing will be easier, and then provides better product design. Functional dimensioning provides better designs. Increases tolerances for production. It gives additional tolerance called bonus tolerance. When you use modifiers, many GD&T tools provide larger tolerances. And then it lowers cost. These 3 benefits reduces part cost reduction. If you don't specify it in the drawing, what is your intent, you can't measure it. If you don't measure it, you can't manage it. If you can't manage it, you leave it to the chance. So let us see one drawing I'll take for example and give you some information about it, how GD&T works. You see there is a pin, a sort of a pin, a component which is shown in 3D on the screen, and then this component is drawn with in the 2D drawing with all requirements here. So how it should be, it goes to an assembly for fitting, fit and function, and then all functional dimensions are toleranced with geometrical features. So you can see now this one by one I will just try to touch upon. I will not take in depth. So there is a symbol which is used here. It is a flatness symbol. So this surface should be flat within 0.1, and this is qualified with the datum. So datum system. With reference to this, other dimensions are measured. So with reference to this datum A, if you come to the opposite surface of the pin here, these two should be parallel for the function. The parallel requirement is 0.4 with reference to A. This is how it is specified. Parallelism is specified here. And then the diameter of this to the axis is positioned with reference to two datums. So diameter is positioned within a tolerance with modifier with the primary and secondary datum. And primary and secondary datum, you see, come to the secondary datum here, this is B. See, with reference to this diameter, this should be positioned with tolerance. Okay, and then there is another datum with reference to A. A is again a surface. To this surface, this diameter should be indirectly primary datum controls orientation. That is, orientation is perpendicularity. It gives the perpendicularity for this, how it should be. This is the functional requirement which is mentioned using GD&T. We come to the other part of it. I will show you this profile tolerance, profile of a surface with datum A here. So it should be, it is qualified again with datum C, and there is an angular hole here. You can see a small hole is drilled at an angle 20 degrees, is kept in a box. It means it is a basic dimension. It is a basic dimension. With reference to this, there is a tolerance mentioned here with the position tolerance with reference to datums. Clearly it is mentioned what is the tolerance for this angle and what is the position for this. And then come to the slot. In the 3D view, you can see a slot is made here for its function. That slot is positioned with reference to datum E. Datum E is this diameter. It is defined here, this datum E. With reference to this, it is positioned to the axis and center plane of this slot should be in line with the axis. So within the tolerance here, it is so clearly defined. And coming to this diameter has a control of a runout tolerance. It's a circular runout. So it should run out within the tolerance specified here with reference to datums and qualified for E. So the design intent is clearly defined with reference to its function, how it functions in the assembly. It's clearly defined. So this is the advantage of using GD&T to make a complete drawing. So now using the skill, GD&T is a new skill. So with this new skill, you can correctly interpret the drawings. You can create drawings as per standards, negotiate drawing change requests in the real world situations, explain inspection requirements, replace coordinate tolerances with GD&T, increase part tolerances without hurting part functions, and to reduce the manufacturing cost. So there are 6 components of GD&T: definitions and rules, concepts, symbols, datum system, tolerance zone requirements, design philosophy. So let us see, these are grouped into 5 types. This is groups actually, all symbols. One is form, the other one is profile, the third one is orientation, location, and then runout. So geometric characteristic symbols. There are 14 symbols which are grouped into these 5 groups. These are the 14 symbols used in GD&T language. Geometric characteristic symbols are a set of 14 symbols used in the language of GD&T to describe the geometry attributes of a part when you design. Facts about geometric dimensioning and tolerancing. GD&T increases tolerances with cylindrical tolerance zone. It gives an additional tolerance called bonus tolerance. GD&T allows the designer to communicate more clearly. GD&T eliminates confusion at inspection. There are some real-world applications which I can just touch upon. If you use GD&T with reference, so where you can use. So sealing applications, like on hydraulic cylinder, sealing application, and then a support application, alignment, balance, wear, and then assembly in a, for example of a bearing application. A straightness of a needle roll bearing is very important for its function and its life. So performance of a bearing. So these are some examples of real world applications. It is important. GD&T is very important because global sourcing requires clear communications. The competitive business environment requires part tolerances to be as large as can be because of the cost. Tight timing for product release requires product problems to be identified and resolved on paper before the hardware is built. On the paper itself, before releasing to production, you can analyze and then find out the defects in the design and then correct it, and then quickly you can release the drawing to the production. Learning GD&T is important to you because competition on good jobs is getting stronger, and knowing GD&T will give you an edge. Knowing GD&T will enable you to do better job, which translates into making more money. Companies are testing prospective employees GD&T knowledge. Knowledge is power. When you practice like a golf or a cricket or a music or bowling, to become a good proficient, you must practice the skill regularly with proper feedback. I'll show you one small example. This is a small part with two feature control frames with a pin which is positioned here for the hole, and the perpendicularity pin is mentioned here. So this is a simple component with simple design requirements, functional requirements. If the part is simple, the GD&T will be simple. You see another drawing. This is a shaft which is used for rotation purpose with a bearing, and then the requirements are different. There is a profile requirement, parallelism requirement, perpendicularity requirement, positional requirements. You can see all these functional requirements. So if the part is complex, the GD&T is complex, will be complex. Facts about GD&T dimensioning and tolerancing. It increases tolerance with cylindrical tolerance zone, allows additional tolerance, designer to communicate more clearly, and eliminates confusion at inspection. In NTTF, GD&T training in PG programs. Animations are used for understanding concepts clearly. Exercises on application on part drawings based on function. Hands-on training on geometric measurements in our lab. I'll show you one drawing. You design a component. The component is designed and dimensioned and toleranced, and then apply. You will learn how to apply geometrical requirements for the function. So it is a skill that you have to learn based on the study of the function of the part, how to apply geometrical tolerances and convey to the manufacturing to the complete drawing to give. So there are learning steps. You will learn the definitions, rules and concepts of GD&T. You will learn how to interpret geometrical tolerances. You will develop an action plan to continue learning GD&T. You will need additional practice to become proficient, as I told you earlier. The amount of material in this subject is very large. The more than 250 terms and concepts are available. GD&T is a large topic. Using what you have learned on the job is a skill. I'll show you some small examples which you need to know about it, and you will learn it is a requirement. For example, a small drawing is shown here, a part of the drawing. A straightness requirement is applied for a pin. The straightness is applied with a tolerance, with a modifier, and to the size. So it is applied to the axis. So how to measure? How to do? So there is an animation which this concept is explained clearly, which every student need to know. Just to see this animation, I will show you. There is a virtual condition, and a gauge is hard gauge is prepared, and the bend is measured. That straightness is measured with the gauge, hard gauge, and if the bend is more than required, it will stop there, and then it will become a bad part. It doesn't enter. Okay, so this is one example. You can see once again, it goes. That means it is measuring straightness. This gauge is measuring straightness. So there are two steps in measurements. One is measuring the size and the geometry. If it is more than the required straightness tolerance along with the modifier, it will not accept. This is one part of it. Okay. Now, entity of PG program will train you on awareness of GD&T, interpretation of GD&T as a symbolic language, application of GD&T in the design process as a design tool, measurement of GD&T, hands-on training, analysis of GD&T in tolerance stack-up analysis. I'll show you one more small drawing with an application of flatness control. So how do you measure this? This animation will tell you the concept, how it is measured. Just watch. Component is to be measured in the bottom surface. So component is kept on a surface plate with a small hole in it. So thus that hole, you fix the dial indicator and into the hole, because the datum surface has to be measured, and then run over lengthwise component. Dial indicator will tell you, and widthwise also the whole surface is measured for its flatness without taking any other reference, because form controls doesn't need any datum reference. There is another example which I would like to show you, a position tolerance. So this pin has a counter bar, and this has to be checked with reference to the outside diameter. And there is a meaning if there is a modifier in the tolerance zone, and there is another meaning, same modifier is used in the datum portion. So taking this shift, this tolerance requirement, and making a hard gauge and checking the counter bar with the plug gauge. See how it works? Total tolerance, position tolerance, bonus tolerance, permissible datum shift, total 2 mm tolerance. It checks here, it doesn't go. Now it is with the shift, it goes green. So this is how animations are made to communicate and to understand the concept clearly. This is another small example. A part is shown here. There is an angle here. This angle, how do you check? So there is a conventional method. Using a sine bar, you can check. This is conventional method. So how do you check? Let us see the animation. See, sine bar is set. The height is set. This is equal to the height. C is equal to h into sine alpha. This height is equal to c into sine alpha. C is the center distance and sine alpha value is multiplied, and you get the height here. The height is packed up with the gauge blocks and prepare the gauge. This is sine bar, and mount the component on that. Run the dial indicator over it to find the angular variations. In GD&T, angular variations are measured in units, not in minutes and seconds. It is easy, and it is easy to measure. Okay, and the angle is considered as a basic angle. The tolerance is provided with reference to the basic angle. It is measured in millimeters, units, easy to measure, quick. Dimensioning and tolerancing in the world, in the globe, actually, there are only two standards. One is dimensioning and tolerancing by ASME, American Society of Mechanical Engineers, that standard. The another standard is ISO standard, International Standards Organization has another standard. These two are international standards. All European countries normally uses ISO standard, and then American countries they use ASME. So, but both are international standards. So both I mean you can learn both easily. Once if you learn one, the other one with the comparison you can learn. Okay, these are the two standards in the world when you prepare drawings. So if you have any questions, contact us, come and join our post-graduation program and build your future. Thank you, and over to Mr. Ramani for further information on our programs. Thank you, sir.
Thank you very much, sir.
Thank you, sir.
Mr. Muralidharamurthy, sir, for introducing the audience to GD&T. You would have got a glimpse of the GD&T with the 4 core elements: size, form, location, orientation, as well as runouts. For this design approach, we have to keep in mind the right tolerances while keeping the manufacturing costs low to achieve the intended results. So now let me introduce you to NTTF School of Postgraduate Studies. NTTF helps young engineers to master the aspects right from idea generation, engineering a product with the right tolerances, designing the tool for mass manufacturing, either it may be plastics or sheet metal, and quality management and process controls. We have specific programs for all these stages of the cycle, and I request Dr. Ramani to detail it to you on how you can acquire these much needed skills and become successful. Dr. Ramani, sir.
Good morning again, my dear viewers. Let me make a small introduction to our postgraduate programs. On the left top, you see the 5-storied building, which is the largest building in that Pina campus in that area. And we have both postgraduate degree programs as well as postgraduate diploma programs. The degree programs are 2-year duration, diploma is 1-year duration. The first program that we started with was postgraduate degree program in tool engineering. That the duration is 2 years. That has started in the year 1983. So far, we have 560 graduates coming out and being employed throughout the world, not only in India. And then later we started the 2-year postgraduate degree program in product design and engineering in 1998. So far 272 engineers have graduated in this and they are well employed. We started 1-year postgraduate diploma in tool design in 2002. This is a popular program because you get employed within 1 year. 606 people have graduated so far and they are well employed. And then later we started 1-year postgraduate diploma program in quality engineering and management, also of 1-year duration in 2005, and so far 154 engineers have graduated. And the first remark is all NTTF programs are recognized by the industries since the day one, and it is evidenced by campus placement of all eligible students. One thing about GD&T, whether you attend any of these programs, whether 2-year, 1-year degree or diploma, GD&T is one of the compulsory subjects. Similarly, advanced material technology is another one, because for cost control, you have to specify the correct material. The material must be correctly specified, the weight must be, because weight is the driver of design cost. And see, people who come to our campus for taking fresh engineers in the alphabetical order, some of them, not exhaustively, are Ashok Leyland, Autoliv. They are manufacturing 70% of automotive safety systems are supplied by Autoliv company, and Bajaj, Brakes India, Caresoft, Caterpillar, CN Technologies Hyderabad, Delphi, and this Fiat, GM, Harita, a Kangaroo that's based in Punjab, John Deere Pune, LG Balakrishnan, that is Coimbatore, L&T, Schneider Electric, Subros, And this is electronic company, Total Connectivity. This is Turbo Energy Limited, and of course TVS Motors. Sundaram Clayton Limited in their foundry division. Then TAGMA is an acronym for Tool and Gauge Manufacturing Association of India, which is founded by NTTF, in which 450 organizations are members, and they keep contacting us. We are in touch with the HR heads of all these companies. So the moment there is a vacancy for fresh talent, they contact us. And so if you are eligible, if you pass with a good grade, absolutely there is no reason why you should not get employed in a company, your own dream company. You can secure your future through NTTF PG School. I wish you all the best and have a great day post-COVID. Thank you.
Thank you.
The question, because the question itself is not very clear.
Yeah.
Which type fixture is used when it is flexible, used as flexible in automobile?
The component is specified as flexible. You see, there is one circle with F means flexible component. So there the pressure applied, the load applied while measuring must be specified. Then only we can repeatability can be ensured. Otherwise, somebody will use greater force, somebody will use less force. There will be problems of acceptance. So flexibility is applicable for the component, not for the fixture.
Thank you, sir. There is one more question which says simple examples to differ unilateral, bilateral, plus minus tolerances.
Basics, very basic. Okay.
So these
sir,
things
can,
definitely taken up.
Yeah, okay.
Yes, sir.
No, if you want, you can give an answer. Say 20 plus minus 0.1 is the bilateral tolerance. 19.9 plus 0.2 is a unilateral tolerance for the same function. 20.1 minus 0.2 is a unilateral tolerance. That's all. I mean, just only to give a passing answer.
Thank you, sir.
Okay.
I think most of our questions are answered, and I think each one would have got refreshed with all these details on the introduction of GD&T. In closing, this is our second webinar this year, and we would love to hear your feedback. Please post in your feedback to us on pgschool@nttf.co.in. If you have any comments, questions, do email us and we'll definitely get back to you. We look forward for bringing much more technical presentations in future. Thank you all. Stay safe. Good day.